So let's go ahead and see what happened in tossing the coin. So when I asked you for the first time, saying, did I trick y'all? So let's say for the first time, when I tossed the coin the first time, did I trick y'all? Y'all said, I'm assuming y'all said no. For the second time, y'all said no. For the third time, y'all said no. As I keep getting constant heads, slowly y'all started to think, is she really tricking us? What is going on here? Right? So let me go ahead and show you the math behind it. H naught, look how I'm trying to put it in H naught and HA. Remember, I'm trying to show you the significance of p-value. H naught, I'm saying I am not tricking. Remember, null hypothesis is not everything is equal. I am not tricking you. I'm not ing, right? And HA, I am tricking you. Okay? All right. Remember how I start my hypothesis testing? I always assume H naught is true. So you are assuming that I am not tricking you. That's how you start. So let me go ahead and show you what the math behind it is. When I have, I'm just going to put x and probability of x. So when I had the first head, probability of having one head is 0.5, 50%. So you all say, you can have a head when you toss a coin, right? When I had two heads in a row, probability of having a head and head, 0.5 times 0.5 is 0.25. Y'all were like, that is still okay. She can still have two heads in a row, right? So that's not a problem at all. Now, what about the next one? Having three heads. 1, 2, 3. That is 0.5 times 0.5 times 0.5, which is 0.125. Y'all were like, yeah, of course, you can have three heads in a row. What about having four heads? That is 1, 2, 3, 4. What's the probability? 0.5 times 0.5 times 0.5 times 0.5, which is what? 0.0625. What about five heads? 1, 2, 3, 4, 5, which is what? 0.03125. This is when you started to have your doubt. You're like, is she really tricking us or not? So when the probability is 50, you're okay, 50%. Probability is 25%, you're still okay. Probability is 12.5%, you're still okay. Probability is 6.25%, you're still okay. But once the probability fell all the way down to 3.125, that's when you started to have your doubt. When the probability of something is happening is so low, you doubt if that really happens or no. Is that really random that she got six heads in a row? No, that's not what you're thinking. I doubt if she's tricking me. And when do you know that? Even without you knowing, your head is actually calculating the probability. After six heads, you're like, I doubt it. So that's where the probability importance comes into picture. So probability of hypothesis testing is probability of having the null hypothesis true. If probability of something is really small, then you know it is not going to happen. So let's go ahead and look at the slides now. So the p-value is the probability, if the null hypothesis is true, for obtaining a sample statistic which value as extremely or more extremely than one determined from the sample data. So when I got the extreme six heads, that's when you started to doubt, is she really tricking us? So that's what it means by probability. When the probability of something happening is so small, that's when the doubt starts to come into your head. Is that even random or something else is going on here? Okay, so let's look at different types of hypothesis testing. So it's left-tailed, right-tailed, and two-tailed. How do I know that? So types of test depends on the region of the sampling distribution. So let me go ahead and show you what I mean. So this is a left tail test. Miss, how do you know it's a left tail test? What you have to look at is look at your null hypothesis. What does your null hypothesis say? Mu is less than. If it says less than, it is to your left hand side. So it's your left tail test. Do you see that? Okay. Now let's go ahead and look at the next one. All right, the next one is a right tail test. How do I know it's a right tail test? You look at your alternative hypothesis. Remember, you do not look at your null. The null does not tell you, only your alternative tells you. Your alternative is greater than, so it's your right tail test. Remember, only alternative, not your null. Now let's look at the next one. The next one, again, I'm going to look at alternative, not my null. I'm going to cancel off my null because it's going to confuse me. My alternative says not equal to. Not equal to means it could be less than or it could be greater than. So remember, there are three types of tests. When your alternative, you only look at your alternative. When your alternative is greater than, it's your right tail test. When your alternative is less than, it's your left tail test. When your alternative is not equal to, it's your two tail test. Okay? How do you make your decisions? Now that you know about the testing, you know about p-value, how do you make a decision? So you take your sample, you do all the math, you get the p-value. Now what do you do with the p-value? The p-value, you compare your p-value to alpha. Remember what alpha is? Your type 1 error. There's only two simple steps. If your p-value is less than or equal to alpha, you reject your null hypothesis. Remember what it is. If the probability of something happening is very, very low, then you reject it. If your probability is greater than alpha, then you fail to reject. Just like flipping the coin. The probability was 3. It is so low that you think I'm really tricking you. So, no, you reject your null hypothesis and say, Miss, you are tricking us. Okay, again, I repeat, if p-value is less than alpha, you reject. If p-value is greater than alpha, you fail to reject. You have to write these down every single time so you can memorize it and you know what is going on. All right, so let's look at the next one here. Once you make your decision, you say, okay, am I rejecting null hypothesis? Am I not rejecting null hypothesis? How do you write them down? This is very important. I repeat, this is very important. So please pay attention. You have two cases here. Remember, you saw that your claim could be your null hypothesis or your claim could be your alternative hypothesis. Anything could be my claim. I could claim something is greater than or something is less than, or I can claim something is equal to, right? Anything could be my claim. So don't go with assumptions that only null hypothesis is your claim. Your null hypothesis could be your claim. Your alternative hypothesis could be your claim. But you always assume your null hypothesis is true. So let's go ahead and look at how to deal with this one. Okay, let me click this here. So when your null hypothesis is your claim and you reject your null hypothesis, how do you say that? There is enough evidence to reject the claim. When your null hypothesis is your claim and you fail to reject it, what would your what do you call it? Terminology, yeah. What would your terminology be? There is not enough evidence to reject the claim. When your alternative hypothesis is your claim and you reject it, what do you say? There is enough evidence to support the claim. When your alternative hypothesis is your claim and you fail to reject it, you will say there is not enough evidence to reject your claim. I'm going to go ahead and do an examples on that so you can actually look and see what it means. So steps for hypothesis testing, I'm just going to move this up. State the claim. Remember, you have to write down. You have to start with your claim, and then you will decide if it's your H naught or HA. All right, that's going to be your first step. Your next step is what is the level of significance, which is your alpha. Alpha will be given to you. Determine the standardized sampling distribution. Do the test statistic. We will be doing all of this in your StatCrunch, so you don't have to worry about any mathematical computations. You will find your p-value. Then you will decide, are you rejecting your H naught or you failing to reject your H naught? And then you'll write your statement to interpret your decision. So strategies for hypothesis testing. So the strategies that you will use in your hypothesis testing depend on whether you're trying to support or reject a claim. You cannot use a hypothesis test to support your claim. When your claim is null hypothesis, you cannot do that. So a researcher to perform a hypothesis test, whether the possible outcome will support a claim, they have to word the claim in such a way that it is their alternative. Why? Because keep in mind, we always assume the null hypothesis is true. So you cannot start with claiming your own claim is true. So if you want to prove or disprove, your claim cannot be a null hypothesis. It should always be the alternative. And to perform the hypothesis test whether the possible outcome will reject a claim, word it so the claim is null hypothesis. All right, so let's go ahead and take a look at our homework.